Hello, Assalamualaikum and a good day to the panels and audience. Today I will present on my final year project, which is entitled Characterization of Copper Coil Winding Wire Configuration for Wireless Solar Power Bank System Development. I am from Faculty of Mechanical Engineering. The presenter is me, myself is Muhammad Harith bin Samsul Iskandar, and this is my student ID. My supervisor is IR/TS Dr. Rozina Binti Abdul Rani. For the project summary, the project focused on the charging system that transfer power wirelessly rather than using traditional copper cables, as well as this device also provide the measure battery charge. The system also will be charged battery wirelessly, and they use power solar as a primary source of the system. The three types of copper coil configuration will be tested to determine the most efficient for wireless power transfer. Also, a complete wireless-based solar power bank system will be developed based on the coils configuration that provide the best performance and efficiency at the end of the result of the project. Okay, so the introduction and background. Nikola Tesla, who is a Serbian and engineering and electrical engineer, he invented and demonstrated the ability to transmit the power and electricity in the air by the method of creating two magnetic fields between two circuits in the late 9th century. Wireless charging also works when there are two coils, which is primary and secondary coil, that created magnetic field between both of them and transfer the power using the magnetic field. Okay, so the wireless power transfer. How can power transfer wirelessly? The first one is alternating magnetic field. It creates induction current coil from primary to secondary coil. At the picture shows the magnetic field that creates between two coils, which is primary and secondary, and the current that come through the coil will transfer through the magnetic field. And how it detects transmitter signal? It detects by the change in frequency and resonance inductive coupling. Okay, so the literature review. The first one is for the wireless charging of electrical vehicle system, which is a few components that need to be looked up for wireless charging. Is the first one is power supply, the second one is charging infrastructure, and the last one is load of the system. Second one, solar driving rechargeable lithium sulfur battery for the power bank system of this project, which is it confirmed that 1.72.82 2.8 volt in lithium cells are monitored to confirm the operational viability of solar rechargeable battery. The last one is review on the inductive wireless power transfer charging for electric vehicle, which is in magnetic resonance coupling. The electrical wave will be created in both coupling of transmitter and receiver coil. Okay, the next one is problem statement of this project. The first one, wired cables are messy, need to change to wireless in this modern era. We also used to carry the messy wire to charge our power bank, to charge our battery, to charge our phone. So we need to change in this modern era. Second one is the usage of the other material beside copper is not efficient and expensive. For example, silver and gold at the metal category. Silver and gold is very expensive, and silver is very reactive to the sulfur in the air, so it's not suitable for wireless power transfer. Next one is to get maximum power supply, it need to be on the sunny day. So the next one is to get the maximum power supply, the solar panel need to be in the tilt angle, and also azimuth angle also need to be considered to get the 5 volt voltage to supply to the system. The objective of this project is to characterize the configuration of copper coil for wireless power transfer. The second one is to develop the system wireless charging using solar as a power supply. Lastly, to determine the ideal height distance between primary and secondary coil of the system. Okay, scope and limitation of the project. Okay, the limitation is the project material need to be used only copper material as is more suitable for wireless power transfer, as is explained before. So the voltage that will be generated to the after transmitter and receiver coil, the output voltage will be maximum to 5 volt voltage, because our maximum requirement for device charging is also 5 volt voltage and 0.5 ampere current. The project also can be only on a sunny day, which is limit ourselves to do the project at the rainy day, because there's no power source. Okay, methodology of this project: first, literature review, circuit and design development, hardware development, copper coil configuration. There are 3 copper coil configuration. 5, hardware implementation. We connect and solder all the component and equipment. 6 is troubleshooting. We try it. And lastly, we testing and analyze the result of the end of the testing. Okay, this is broad diagram that show 2 parts of the system, which is transmitter and receiver coil, and there's a component in there that we can refer to the next slide, which is this system that has been set up in this semester. There are 8 components in total to make the power from the solar panel to charge the lithium battery at the end of the system. Okay, so the expected result of this project is solar panel can absorb maximum sunlight to supply 5 volt voltage to the system. Voltage regulator, as we can see at the blue one, will be step up the voltage if the power of output in the output module is not exceed to 5 voltage. So the voltage regulator will step up it to charge the lithium battery with the 5 volt stable DC current. Also, lastly, is position of transmitter and receiver coil need to be aligned to get a proper magnetic field to get high output voltage. Okay, for the preliminary result of this semester, there's 3 picture in this slide. The first one, this preliminary result also will be testing on the parameter of height distance between receiver and transmitter coil, the configuration. So the first picture shows that 0 mm of height difference, output voltage is 5 volt, which is the maximum that we want to charge our battery or phone. The second picture, it shows 5 mm height difference between transmitter and receiver coil. The voltage is slightly lower, which is 4.93 volt. And lastly, I move a bit higher to test it out. There's no output voltage. It means there's no magnetic coil, magnetic field for both transmitter and receiver coil that transfer the power wirelessly. So 0 voltage volt at the output. Okay, what can we discuss from the result? Okay, the efficiency of the system become lower when the height difference is increased. This is related to magnetic resonance coupling. The copper coil has a strong coupling state. The lower the height difference, the higher the output voltage we can get. Meaning in the picture we can see there's has a strong coupling state to move throughout the magnetic coil between 2 coils. So the higher the distance, the magnetic field will be broad. So there's a low output voltage at the output of the transmitter module. Okay, so this is a 3 copper coil configuration that will be tested to get a most efficient for wireless power transfer power bank system. Okay, the first one is height distance of primary and secondary coil that have been done for this semester, and 2 more will be tested for next semester FYP2, which is the number of copper coil turns, which is I will test for 10 turn, 15 turn and 20 turns. Next is shielding material. Shielding material is the material that will be put between transmitter and receiver coil, which the material will be tested probably will be paper, aluminium, plate and also plastic to get where and to know what is the material that suitable for wireless power transfer. Okay, so next, further planning for research work. The first one is analysis of wireless charging system with multi-domain oscilloscope to get the digital oscilloscope data. Next one is testing for the number of couple coil turn for both receiver and transmitter coil. Propose the final design for most efficient wireless charging system. And lastly is testing for the shielding material for wireless charging system. Okay, that's all from me. Thank you for listening. If you have any concern and to ask me a question, you may reach at the comment section below, and also to my email, student email, and also my personal email is muhammad.harith187@gmail.com, and also my number is there. Okay, thank you.